Hello, Math Wizards! Welcome to a new lesson episode of Just Math PH. So, for today's lesson, our topic, you will be learning about reducing equations to quadratic equations. The objective for this lesson is you will be able to solve equations transformable to quadratic equations, which includes rational algebraic equations. Before we will start the lesson, let's first have a review on finding the LCM or least common multiple of the following numbers. Example 3 and 6. So remember, we are to find their common multiples, but we have to choose the least multiple. So let's write the multiples of 3 and 6. So let's stop if we find their common multiple already. So for 3, the multiples of 3 are 3, 6, 9, 12, and so on. For 6, we have 6, 12, 18, and so on. Now, notice that their least common multiple is 6, right? Therefore, the LCM of 3 and 6 is 6. LCM is 6. Now, how about 4 and 7? What is the LCM for 4 and 7? So let's list their common multiples. So for 4, we have 4, 8, 12, 16, 20, 24, 28, and so on. For 7, we have 7, 14, 21, and 28. So here we already have the common multiple, which is 28, which is the least common multiple of 4 and 7. Therefore, our LCM for 4 and 7 is their product, which is 28. Next example, we have to find the LCM of 5x and 10x. So notice we have coefficients for here we have 5 and 10. So let's write the multiples of 5 and 10. We have 5, 10, 15, and so on. For 10, we have 10, 20, 30, and so on. So their LCM should be 10. So for the LCM, for 5 and 10, it will be 10. Now, how about for the variable x and x here? So since they have common variable x and they have the same exponent, which is 1, so their LCM would be, we would just write x here. So the LCM is 10x. Now, if ever we have here 10x squared, suppose this one is x squared. So here, the highest exponent is 2, while here, it's 1, x to the power of 1. So since we have the highest exponent, which is 2, then our LCM should be 10x squared. However, in our previous example, they have the same exponent, which is 1. So we will just copy x here. So the LCM would be 10x. Number 4, let's find the LCD of x and x plus 1. So x is a different expression with x plus 1 because x plus 1 is already a binomial. So for our LCM, it will be the product of x and x plus 1. So x times x plus 1. So it can also be written as, we can distribute that one. So x squared plus x times 1, which is x. But most of the time, it is easier to write LCM in this way, especially if we are solving rational expressions. So if you write your LCM as this, or if you want to write it like this, it is okay. But in solving rational expressions where we will use their LCM or the LCD, then it's better to write it in a factorable form. For to example, transform the square of x plus 5 plus the square of x minus 2 equals 37 into the standard form. So we have to expand this first and this one also. So expanding that, x plus 5 squared plus x minus 2 squared equals 37. So let's expand this one. So x plus 5 squared, meaning you are multiplying x plus 5 times x plus 5. So our base is x plus 5, our exponent is 2. So there are 2x plus 5 here, and we have to multiply. So x times x, you can apply FOIL method or distributive property. So x times x, that is x squared, and then x times positive 5, that is plus 5x, then 5 times x, that is positive 5x, and then positive 5 times positive 5, that is positive 25. So we can combine these two because they have like, or they are like terms. So meaning that is x squared plus 10x plus 25, meaning 5x plus 5x, that is 10x. So we already expanded this one. So how about x minus 2 squared? So plus, so let's expand that one. That is x minus 2 times x minus 2, right? So x times x, that is x squared, x times negative 2. Remember, that's negative 2. So that is negative 2x. Negative 2 times x, so that is negative 2x. Negative 2 times negative 2. Negative 2 times negative 2, so that is positive 4. So plus x squared, this one can be combined. So negative 2 plus negative 2, so same sign, keep and add. So that is negative 4x plus 4. Okay, so meaning we combine negative 2x and negative 2x, it becomes negative 4x. Then we just copy plus 4, and then do not forget to copy equals 37. So equals 37. Next, we notice that we also have similar terms here. X squared is similar with x squared, right? And 10x is similar with negative 4x. 25 is also similar with positive 4. So we can combine them. So we place them besides each other. So x squared, transfer this one here, plus x squared, and then copy 10x. Place negative 4 beside 10x, so negative 4x, and then copy plus 25. Then place 4 beside 25. Right? Are we done? So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 equals 37. So let's combine them. So x squared plus x squared. So remember that we have invisible 1 here. So 1 plus 1, 2. Then we will just copy the literal coefficient, x squared. So we already combined that one. So the combined is 2x squared. And then combine 10x minus 4x. So 10 minus 4, that is 6. So positive 6. Then copy their literal coefficient x. And then how about 25 and 4? So 25 plus 4, that is 29. Now 37, we will transfer 37 on this side. So that is negative 37 equals 0. So copy 2x squared. So that is 2x squared plus 6x. So 29 minus 37. So since 29 is positive and 37 is negative, we have to subtract them because they are different signs or unlike signs. So 37 minus 29, that is 8 equals 0. Now, if you notice, actually 2x squared plus 6x minus 8 equals 0 is in the standard form. But since our topic is reduce standard form, I noticed that 2, 6, and 8 can be divided by 2. It can be reduced by dividing each term by 2. So what we will do, we will divide all of these terms by 2. Thus we have x squared plus 6 divided by 2, that is 3x. 8 divided by 2, that's negative 4 equals 0. Thus, x squared plus 3x minus 4 equals 0 is the reduced standard form. Now, some rational equations can be transformed into quadratic equations. So what are rational equations? So obviously, these are equations that have fractions in it. So um, let's have an example. Transform 2 over x minus 10 equals 0 into a standard quadratic equation. So to do that, so let's first copy 2 over x minus 1 equals 0. So we have here the denominator x, okay? And then notice that our denominator here are 1, right? Since we can't see any visible denominator, it's obviously their denominator is 1. So what is the LCD of x1 and 1, or the LCM of x1 and 1? So the LCD is x. So what we will do with our LCD x? So LCD or our LCM is x. So what we will do with our LCD x? So we will multiply it to our rational equation. So multiplying it, so we will multiply it on both sides, x, and this one times x. So our pattern would be multiply above and then divide below. Again, multiply above and then divide below. So x times 2, that is 2x, divided by x. So x times negative x, that is negative x squared, okay, over 1. So we may not write over 1 anymore. So x times negative 1, that is negative x. 0 times x is basically 0. So let's divide. So 2x divided by x, so Notice that x here is a common variable. So we can remove that one. Then what is left is 2 over 1 or just 2. So we will just copy x squared and negative x squared and minus x. So negative x squared minus x equals 0. So from the original rational equation, it become like this. So 2 minus x squared minus x equals 0. Now, since it's not arranged, do not forget to arrange it. So let's place negative x squared here, then followed by negative x, and then followed by 2. What should be the sign of 2? 2 here should still be positive because we did not transfer it to the other side. We just arrange it. Now, since our a here is negative, to simplify it, we have to multiply negative 1 on both sides. So negative times negative, that is positive x squared. Negative 1 times negative x, that is positive x. Negative 1 times 2, that is negative 2, equals 0 times negative 1, that is 0. So this is the reduced quadratic equation in the standard form for 2 over x minus 1 equals 0. So this is the reduced quadratic equation. Reduce the equation x squared minus 7 over 20x plus negative 3 over 10 equals 0. So look at our denominators. We have here 20 and 10. So what's the LCM for 20 and 10? So remember our LCM review earlier. So let's list the common multiples of 20. We have 20, 40, and so on. For 10, we have 10, 20, and so on. So their LCM is obviously 20. Therefore, our LCD, because it's already in the fraction form, would be 20. Now, what we will do with the LCD again, we will multiply it to each terms of our equation here. So 20 times, so copy x squared minus 7 over 20 x plus negative 3 over 10 equals 0 times 20. So 20, remember the x squared here has a denominator 1. So 20 times x squared, so that is 20 x squared. So we might not write anymore over 1 here because it's already understood. Then 20 minus, 20 times negative 7x. That is negative 140x. Copy over 20. Copy this one. 20 times negative 3. So this plus negative 60. Copy over 10 equals 0. So notice that we can divide negative 140x with 20 and as well as with negative 60 and 10. So let's divide it. So first copy 20x squared and then divide negative 40 divided by 20, that is negative 7x. Negative 60 divided by 10, so that is negative 6 equals 0. So this is our reduced form, which is 20x squared minus 7x minus 6 equals 0. So that is our reduced quadratic equation. example, solve 2 minus 4x squared over x equals 3 minus x over 2. So in the SLA lesson, this was solved using the LCD. However, in this video, I will solve it in a different way. So since we have here an expression on the left side and it's equivalent to another expression on the right side, what we can do or what you will do is we will do cross multiplication. So to do cross multiplication, we will multiply 2 to this expression and x to this expression above. So multiplying it, it will become 2 here times above, which is 2 minus 4x squared. Do not forget equals. Then multiply x to this expression. So x times 3 minus x. So that is cross multiplication. 2 times this and x times this one. So apply distributive property. So 2 times 2, that is 4. 2 times negative 4x squared, so negative 8x squared equals x times 3, so that is 3x. And then x times negative x, so negative x squared. Since it has an exponent 1 and 1 here, loss of exponent, we will add them. So this is our we have here now 4 minus 8x squared equals 3x minus x squared. So what we will do, we will transfer everything on the left side of our equation. So for, let's place minus 8x squared and then place negative x squared beside this one for easier solving. So it becomes positive x squared since we transferred it here. Then minus transfer 3x, so minus 3x equals 0. So again, we transferred 3x to the left side and negative x squared to the left side. So we can combine this one. So remember that we have here an invisible 1. So we have to add negative 8 plus 1. Since they have different sign, 8 is negative and then 1 is positive, we will do subtraction. So 8 minus 1 is 7. And which is bigger, 8 or 1? So obviously it's 8. It's 8. Now we will copy the sign of 8, which is negative. So it will be negative 7x squared. Okay, for this one, right? Okay. So do not forget to copy 4. Okay, 4 minus 7x squared minus 3x equals 0. So let's arrange it. That is negative 7x squared minus 3x. Then last is the constant, so plus 4. Do not change the sign of 4 because we did not transfer it. So since this one is negative, we will multiply by negative 1 on both sides. So we have here 7x squared plus 3x minus 4 equals 0. So this is the reduced standard form. So since the instruction is to solve the equation, so using this reduced standard form, we will find the roots. So let's write here, let's find the roots for 7x squared plus 3x minus 4 equals 0. So this one can be solved using Vedic because it's factorable. So let's identify A. A is 7, B is 3, and C is negative 4. So remember Vedic, we have to multiply A and C. So A times C, that is negative 28. Then we will find two numbers that when multiplied, it's negative 28. But if we add them, it will be our b, which is 3. So what are the two numbers when multiplied? It's negative 28. And if we add them, the numbers, then we will have 3, positive 3. So 7 and 4. So since it's negative, the negative should be here, because if we add them, the sign of the sum is positive 3. So 7 should be positive. 7 times negative 4, negative 28. 7 plus negative 4, positive 3. So these are the two numbers we're looking for. Afterwards, we will divide these numbers by a. Divide it by a. So dividing by a, that is 7. Here, 7. So 7 divided by 7, that is 1. And negative 4 divided by 7, so that is negative 4 over 7. Again, do not forget to change their signs or to flip their signs. Then we have negative 1 and then positive 4 over 7. This is, or these are the roots, not this one. The roots are the flip of the numbers or the change signs of these numbers.